we have our two functions multiplying. We pulled out the 24, negative 24. This function is of the form something to a number. The n is 2, the something is x. So we want to talk more about that. Okay, it's called u substitution because you are going to take an antiderivative that is written with the variable x, and you're going to substitute every x for something using u. So we're going to make a u substitution. That's why it could be w, it doesn't matter, it's just more fun to say u. So, the u that you pick is always the something. So this is something to a number. Like, that means the u is something. The u is x. The u that you pick is always the something. But you've got two functions multiplying. Therefore, you have two possible somethings. So there's another one. This function is not of the form something to a number. This is of the form e to the something. As Sarah said, e to the something. And the something is always u. Question. The something you choose is always u. The u that you pick is always the something. So that's the first step. Identify the two multiplying functions. Notice that the two functions are of a specific form. That allows you to identify what the something is for each function, and that becomes your choice of u. Question. Please.
How do you choose the two?
Only one will work, usually. So what we do is a test now. Say it out loud, please. What's the derivative of x? Louder? 1. 2 points per kilo. This choice of u came from this function. For u substitution to work, the derivative of this something must be this function. And it's not. So wrong choice. Please. Absolutely. I do not blame you. The first time I watched u substitution, I'm like black magic, like sorcery. Sorcery. Is that how you say it? Sorcery. Dinner plates. Like spaghetti sauce. Sorcery. Wow. Oh boy. Wow. That's a chew, right? Is that right? That was a chew for sure. Am I using the words properly? Wow. How is that, G? Sorcery? Sorcery. But sorcery. All right, one more try. Wow. Okay. The key to u substitution, look, it does feel magical. It's like, wow, this is a weird process. It is. The key is identifying the two multiplying functions, identifying which form do both functions take. So the first function is definitely something to a number. The second function, e to the something. The only other kinds of forms you're going to run into in our class are 1 over the something, sine of something, cosine of something, which match up just like the pink sheet. If you look at the pink sheet, that's the same kind of pattern. Okay? So, once I know this, I can pick my something. Here the something is x. Here the something is 2x cubed plus 1. Now you do the test. First of all, I can tell you this. If u equals x, that's not going to help. Because if all you do is rewrite this with a t in place of x, you haven't changed anything. If you rewrite this with a u in place of x, you haven't changed anything either. So that never helps. But the other test is, take the derivative of this. What's the derivative of x at? 1. This choice for u came from this function. Therefore, the derivative should be this. Since it's not, bad choice.
Wait, so the derivative
No, let me see if you're okay. This choice for u is the something from this function, right? The derivative of that choice should be the other function. That's the test. So let's keep going and then you'll see how it works. So I'm going to do the same thing here. I'm going to take the derivative of this. Look, this says dx, so over here it's got to be dx. So just like unit 2, we take the derivative of both sides of the equation. So don't say it out loud, I'd just like you to raise your hand. What is this derivative? Hands up. Whoa. What's this derivative? Cooper?
6x squared.
So this side I can't do anything with. It's just du dx. How many knew it? 2 points, 3 for Cooper. Okay, here's the test. This something came from this function. The derivative of this something should be this function in its entirety. The one thing that can be different is this has a multiplying constant of 1. This has a multiplying constant of 6. Not a problem. We'll factor that out. So the match worked. The key thing is to keep using those two different words. Like I keep referring to this function and then the something that came from this function. So your choice for u is always the something, but the match has to match the function. So this something came from this function. The derivative of this something must be the other function, not the other something.
It has the 6 in front, so just...
Right. The multiplying constant is okay.
Okay.
Yeah, this one has a 1. This has a 6. We'll just move it out of the way in a minute. So, as long as the function itself matches, we're good. The multiplying constant can be different. Again, it's a mouthful this first time through. The good news is it does get very patternistic. Like you start to see the patterns and then it goes pretty smooth. Pretty good? So we can keep going because it's going to work. Okay, it's called u substitution because you substitute. So over here I'm going to start substituting. That's a real word. Just sounded funny. Okay. 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 We are going to put in place of 2x cubed plus 1 the letter u. This will become e to the u. Right? Okay, it works best to write that first. These two functions are multiplying, so the order doesn't matter. So I'm just going to write that first. So this equals negative 24 antiderivative e to the u x squared multiplied by dx. Question? The funny thing that happened last year in A2 was I kept saying this stuff like, u is something, and Mikhail Dahl and Eli Lysenko go, oh, it's like the movie. Like what? Like the movie The Help.
Oh, yeah.
Yeah, where the maid says, you is special, you is kind, you is something. It helps you remember. Just remember the movie. You is something.
Why did you switch them?
Oh, you'll see in a second. 2 points.
When you were talking, you said the derivative of something must equal the function.
So you were talking before that x to the power of 2, well, just x is something. But then later, when you said 6x squared, then you said that that's a function.
Yeah, I get you. Let's just say it again. You're doing great. You are doing great. So you start out with, I have two functions multiplying, right?
Yes.
Okay.
Oh, never mind.
You're good.
Yeah.
Good point. Anybody else? Awesome. Okay, here's Kaylee's question. I start with an antiderivative that uses x. I've got to migrate to an antiderivative that only uses u. Or if you want to make the grammar sound really bad, you must migrate to an antiderivative that only uses u. Make the English teachers choke. Okay. So I got to get rid of the x squared dx. It's called substitution. I need something that I can substitute for x squared dx. Look over here. This just needs to be rearranged.
Oh, you funny.
So algebra.
Yeah, you take the du dx, go on the other side of the 60.
We want to leave the du there, but this is just a fraction. It is literally du divided by dx. We don't think of it that way often, but it is. Change in u divided by change in x. So I'm going to multiply both sides by dx. Black magic. Sorcery. That's funny. Sweet. Easy sauce. Okay. That's slang as well. Oh, magic sauce. You haven't heard that one? 10 years ago. When you teach, your brain just scrambles. Like all the words don't make any sense anymore. Just slang keeps changing. Good here? Now what?
Oh, and then you divide by 6.
Yeah, I get the 6 over there.
Oh, so you
But
can.
then what do we do with this x?
Multiplying constants are never a problem because they factor out. The 6? Oh, because when you have an equation, I want to multiply this side, I want to divide both sides by 6. Or multiply both sides by 1. You see it? Yeah, you see it. 2 points. There you go. Please.
Do you plug in the 2x flow of something into the u on the bottom or no?
Oh, like the u here?
Yeah.
Oh, hold on. I already paid you a ticket, huh? Today? He's like, what's wrong with 2? Look up. Look up. The symbol du is not the same as the symbol u. Yeah, u is, sounds stupid. U is u. U is u, but du ain't. And then we could be mean and say, duh. So, no, just kidding. You knew that, right? Yeah, I feel bad now. Hey, my sins. Du is just du, so it's different. It's okay. Touch it. It's perfect. Yeah, du means the infinitesimal change in groups.
So I thought you couldn't like move the dx. Like I thought.
Like these were inextricably connected.
Yeah. So like.
Keep
why,
talking.
Why can you do that? Like, because du doesn't really. Does that like mean something?
When we first introduced this symbol, we took not a lot of time in this class because we didn't have the time. We spent a little bit of time explaining that this is really just a fraction. It really is the change in u divided by the change in x.
So then now it's like 1/6 the change
In u, yeah. Like it doesn't make a lot of mental sense. It really doesn't.
Yeah.
So I have to tell you that with u substitution for our class, this is one of those few times where I will say to you, please don't try to make sense of it. It's not easy. Make sense of the steps. Like make sense that it is legal. We're just finding things that are equal and making replacements. But the how do you say that?
Sorcery.
Sorcery, thank you. The sorcery, the sword, yeah. Okay, this, never mind.
We now know the
Sorcery. The black magic of it all is that it does work, but it doesn't feel, it feels weird.
So then, doesn't the du like depend on the dx? Like, because it's like for a specific like point in time, right?
Think of it this way. What this is really saying, this is, I'd pay you another one, but I can't. Look, she's like, we're not. Look,
Thank you.
what this literally says, no, you guys can make sense of it, look. What this literally says is, if x happens to be 1, what's 1 squared? 1. The infinitesimal change in x just happens to be 6 times more than the, am I doing that backwards? No, the infinitesimal change in u happens to be 6 times more than the infinitesimal change in x. 1x is 1. That's what it said. Didn't help you much, but that's what it says.
Okay.
Yeah. Don't worry about it.
Okay.
Yeah. For u substitution, just knowing the manipulation is good enough. But you saw that, right? Yeah, that's what it says. If a 1/6 the change in u is the same as the change in x, that means this is changing 6 times faster than this.
Will there ever be a problem where you have to use 2 different intervals, like if you
Not for our class. Point.
So then, do you ever use the u equals x?
It won't work.
Okay.
Yeah, it won't work.
Because like you did the test, but then.
The test failed, which tells me that's not a
So
good
then you
choice.
just don't.
abandon that
Okay.
path. Yeah, it just won't work. U substitution doesn't always work. So we've never, it's a technique that's selective. It works sometimes.
So how do you know that the u is like the 2x cubed plus 1 and it's not just like the x cubed?
Mostly because of the way I'm teaching you the technique. There are other ways to solve this problem. I just found them to be more difficult to learn. So the method I'm teaching I found to be the easiest. And so I just follow that pattern. And again, there'll be some exceptions in the future, so don't freak out when I'm like, okay, here's the exception. But if you learn this method, the exceptions are pretty easy. So I just go back to the pattern, which is I identify 2 functions that are multiplied. I find out which of these 5 forms I have. I remember the movie. U is something. U is special, U is kind, U is important. Whatever. You should see the movie, it's really good. My choice for U is always the something. And then I test. I take the derivative of this choice. The derivative of this something should be the other function, not the other something. It isn't. The derivative of this something should be the other function. It is.
So if it's like cosine of 2x cubed and then like that plus 1, it wouldn't be like the same, right?
No, it has to be the exact match, except for the multiplying constant. Exception minute.
I think so.
Let's
Well,
keep
like-
going. Go ahead.
So like if it's like the cosine of something plus something else,
If you don't have 2 multiplying, like tell me exactly what to write.
like cosine of 2x cubed, and then close the parentheses, and then like plus something else.
Okay, if you have functions, adding U substitution doesn't typically work.
Oh, so
It has to be
it's
2
just
functions
different.
being multiplied.
Oh, okay.
It's just different. You have to use a different
So it's just
technique.
like the whole thing that's like the something, it's just like the whole thing.
No. You start by saying, do I have 2 functions multiplying? Yes, right? Find out which form they are. Something to a number.
So then like within the form, it's
Yes,
gonna be the whole
that's the
something.
something.
Oh, okay.
Yeah.
So like everything that's in the, like parentheses.
Correct.
Okay, it's just
But
like
look,
everything.
There don't have to be parentheses. Parentheses are just a symbol representing whatever. Like there's no parentheses here, but the something is still the x. Yeah, 240. Okay, let's keep going. So this can be substituted now. Questions? Please.
Where did dx go?
So right here it says x squared multiplied by dx is exactly the same thing as 1/6 multiplied by du. 2 points. There you go. Now you have 3 things being multiplied, 3 factors. You can factor out the 1/6. That's why the constants, their multipliers don't ever matter. They don't get in the way. You just keep factoring them out. Okay, that's what we wanted to do. Look up here. You have an antiderivative that uses x. It's complicated. This magical method did a transformation. You now have an antiderivative that uses u, and it's not complicated. Now you pick up the pink sheet, and you say, that's easy. The antiderivative of e to the u is just e to the u. That's it. The last thing you always do is use the pink sheet. You transform everything to u and then use the pink sheet.
Sorry, I kind of zoned out.
You're fine.
Is that because e to the u is constant and it is?
No, good question. So u is a variable,
Okay.
but if you look at your pink sheet, the pink sheet says the antiderivative of e to the x is just e to the x. No worries. And we're just using the letter u instead. Yes, we'll do that at the very end, because it's just kind of the afterthought.
Is it not?
Not quite. That's a drop. Are we not done? There's more.
So if this is an FRQ problem, do you want to make sure that you clarify that what u equals and you have u as the answer?
You can't leave it like this, because you can always stop if all that is left is add, subtract, multiply, and divide. But we still have a tiny calculus step. So to assuage, that's the right word, to soothe Achilles, calm her down. All it is left to do is to plug back in for u what u is, which is really good grammar. So I think it's awesome because you can say all these things that just sound terrible, and you're not using bad grammar. It's correct, you know.
But then people care about grammar.
Oh no, that just makes them wince, but then you have to go, oh no, it's correct. So u is something. Hello. The plus c just always at the end. I can guarantee you, you take this derivative, you get that. Oh, look at this. I keep saying, think of the test. Over here I said, you have to have 2 functions that multiply, right? And we identify the forms, like I said to Megan. And we pick our somethings from the forms, right? And then the derivative of our something is supposed to be the other of the 2 multiplying functions, right? Here's why. U substitution is the chain rule backwards. Watch this. Ignore the -4 for a minute. C derivative C is just 0. The derivative of e to the something is e to the something. Listen to the words. The derivative of e to the something is e to the something. Right there, e to the something. Multiplied by the derivative of that something. What's the derivative of 2x cubed? 6x squared. There's the x squared, the constants all just kind of work out. That's why it works.
Multiplied by the -4 again.
That's why it works. That's why it works. That's why I keep using that word something.
So if you're trying to using the text and like none of them work, then you just don't use it.
Yeah, hey, listen to Megan's comment. In our class, it is not like Calc 2 where you have to know, like, I don't know, 6, 7, 8 different methods. And when you take the final at the end of the year, you have no idea which method to use, so you've got to learn how to pick the right method. For our class, only 3 choices. It's either going to work right away with the formula, piece of cake. If there's 2 functions multiplying or a few exceptions in the future, use substitution or some little bit of algebra. But you always finish by using the pink sheet. Like the last thing you do is always the pink sheet. So, almost last. So if use substitution doesn't work, it's got to be one of the other 2 options. Because they have never, ever had given a problem where the answer is, oh, we can't solve it based on our knowledge. So. And they don't really want to have an answer be no solution, because maybe there is, just a different technique. So. That's your question. Okay. Are we good here? Or you want to talk more about this? Please.
So I'm a little bit confused on, so we found, so for e to the something, we found the derivative of that and found that it was equal to the x squared, the other function. And then we used that like equation to du divided by dx equals 6x squared to find how we should substitute u for the x squared.
Yeah, let me say it back. Let me say it back to you. Okay. You start with 2 multiplying functions because when you use the chain rule, that's what you often get. When I take the derivative of e to the something, I get e to the something multiplied by the derivative of that something. So that's why we start with 2 multiplying functions. It's also why we keep focusing on the something. Like, when you get good at use substitution, look at me. You can do the test in your head. Watch this. I just look at it and go, oh, wait a minute, look, I can see it. The derivative of 2x cubed plus 1 is 6x squared. So I right away know it's going to work. This is going to become e to the u. And I've got to replace the x squared times the dx. And that's what this is for, is to figure out what can I replace x squared dx with. Does that answer your question? Good work. Please, Tom.
Is it possible to have a constant for u?
No, because the derivative of a constant would be 0, and that's not going to work. But, hey, hold on. That's the exception that does work, kind of. One of the 2 multiplying functions can be a constant. Okay. Yeah, we don't run into that right now, but we will in the future. One of the 2 multiplying functions can be a constant,
Okay.
and the use substitution will still work.
Okay.
Sometimes. Please.
I don't know if this was asked earlier, but is it possible for the u's to ever equal both of them? Like,
I don't recall that ever happening.
okay.
I don't want to say it can't because I don't know. I have seen a case where, for sure, this has been a pretty tricky AP question that's happened, where both somethings are the same. And we'll worry about that later, and then you're like, well, which something do I use? And one works and one doesn't, even though they're the same. That sounds weird. No. And like I say, I'm trying to make, this is the 7th video I've made, so try to get them all